Okay, so the last time I saw you guys, after we took our quiz, we went through and we looked at a situation about the US World Cup. Remember, in order for something to be a binomial distribution, you have to have two outcomes, independent trials, fixed number of trials, and same probability. You want to think of terms of bins like we did earlier. And then remember, we went through, we made a sample space, and then we talked about how to do NCR in the calculator. So if we look down where we left off at 2E overall, what is the probability that the team will score exactly 4 of the penalty kicks using the formula? And we're going to identify what that formula represents. So the 5, remember that was our 5 different ways. Okay, so this is our number of ways. Okay, the 0.7 is our probability that we make it. 4 is the number of makes. The 0.3 is the probability that we miss, and we have number of misses is just 1. Okay, so we just would type this into a calculator. Now, if I were to look at my formula sheet, remember we wanted to find what our random variable is. We're going to have the number of penalty kicks made. And then we set up NCRP of x equals 4. Remember, we can use our NCR, which if I wanted to use the calculator, I can. It's under probability. We have 5 total. We want 4. And this is 0.7 to the 4th times 0.3. So remember to do the 5 choose 4. I'm thinking in my brain, I'm going to type in 5 first. Then I'm going to push the math button. I'm going to select arrow over to probability, and then select option 3 NCR. Okay, and then I would go from there. Once we do this, we should get the same answer we had in part E, which is 0.36. Okay, which we skipped up here. So overall, what is the probability the team will score exactly 4 of the penalty kicks? Okay, so remember we have all of the different ways to make exactly 4. We have 5 different ways we can do that. So up here, we're just going to take our 0.0723 plus 0.0723 plus 0.0723 plus 0.0723 plus 0.0723, or we're just going to multiply that value by 5. Okay, so if I go to my calculator, it is about 0.3615. Okay. So notice if a World Cup game ends without a shootout, what is the probability that the US team actually wins? Remember, to find this, what I want to do is I want to make 4 or 5 of the penalty shots. So if we go up above, we found make all 5. We found that earlier to be the 0.16807. Okay, so 0.16807, the probability of 4 we just found, 0.3615. Okay, so we would just add these together, and we get 0.52957. The end. Okay, in the second part, it's time for a pop quiz. I hope you're ready. The quiz consists of 5 multiple choice questions. Each question has 4 choices labeled A through D. Here's the bad news, you don't get to see the questions. So I want you to take a second or two and fill out your 5 answer choices, and then we'll reveal the correct answers. Surprise, answer to number 1 was C, 2 was C, 3A, 4D, and 5A. So in number 1, you're going to list your number of correct, and then for number 2, it says X is going to be the number of correct guesses. Is this a binomial setting? Remember, I like to think of that bins where we have B, which stands for binary. So we have 2 outcomes. We're either correct or wrong. Okay, remember I stands for independent trials. We're going to say independent, right? Because the guess of the first question is not going to affect the answer of the second. Remember, the N is number of fixed trials. In this case, yes, we only have 5 questions. And then remember the S is same probability. So if each answer is equally likely, we have the same probability in this case, which is P equals 0.25. 1 out of 4 is correct. So we would say, yes, it's binomial. Okay, if we wanted to calculate the probability of getting exactly 2 right, and we wanted to, and it says to show your work. If it says to show your work on the formula sheet, the binomial formula is there. And our random variable is defined up above as X is the number of correct guesses. Okay, so what we would do here is we would say the probability of our random variable, oh my goodness, X equals 2. We start well with our how many questions? Well, we have 5 choose 2. Our probability of success is 0.25. We want 2 correct answers, and therefore our probability of failure is 75%. That means we have 3 incorrect answers. Okay, now earlier we talked about using NCR and then typing it in. The calculator, however, as long as you have the formula set up correctly, will actually do the binomial calculation for you in one step, and it will speed up your process. The trick, though, is I would still write out your formula. If you are going to do the binomial PDF statement, you need to label NP and X. If you do not, there is no way for you to get an essentially correct. Now, to get to the binomial PDF, what you're going to do is you're going to push the second button, and you're going to go vars, which is down by the down arrow key. So second vars, and I'm going to go all the way down the binomial PDF, which is letter A. Okay, now if your stat wizards are run, your trials is N, your P is your probability of success, and your X value. If it is not on, you just type it in exactly like we wrote in our parentheses. Okay, and it should give you a value of about 0.2637. Okay, which is the same answer you get if you use NCR. Okay, now what I want you to do is I want you to take a few minutes and try to complete the table, and then we will reconvene. Okay, so for your table, for 0 correct, all you would have to do is 0.75 to the 5th power. You could use a binomial PDF, but you will get the same answer. In exactly 1 correct, you should get 0.396. Again, you can either use the binomial formula or use binomial PDF. For 2, we already found that one and just rounded to the 3rd decimal place instead of the 4th. For number 3, approximately 0.088. For exactly 4 correct, 0.015, and then for 5 correct, we could just do 0.25 to the 5th power if we would like to. So look what we are doing next. We are going to calculate and then interpret the mean of our distribution. So we found the mean in our earlier in our second part of our unit and in the first part. But remember, to find the mean, what we would do is we would take the number of correct times its probability. And then we would type it exactly like we see into a calculator. When we do so, we do get an average of approximately 1.253. And then remember, what we would do is to interpret that, we could say after many, many quizzes, the average correct, or the average number correct, is about 1.253 questions on average. Okay, so what you will find now, there is on your formula sheet, there is the mean and standard deviation for a binomial distribution. What it looks like, mu sub x is equal to n times p. So if we took our 5 times the probability of success, right, so 5 times 0.25, we also get 1.25 questions correct. Okay, so I'm going to use technology to find the standard deviation. I will write out the formula and then we will go from there. Okay, so if you do the formula for standard deviation and you go through the number correct minus the mean squared times its probability, you do get about 0.9698. If you were to type in the table into list 1 and list 2 and then 1 variable stats with L2 as the frequency list, you do get something very similar, about 0.968 as well. When we do our interpretation, remember we can say the questions correct on a quiz typically varies by about 0.9698 questions from the mean of 1.25 questions. Now, if we were to look at our formula sheet, we would find our standard deviation of a binomial distribution is the square root of n times p times q, or 1 minus p. Okay? So if I were to take the square root of 5 times 0.25 times 0.75, I should get approximately the same value, which is 0.968. Okay? Now, the probability of getting at most three correct, okay, so at most would be less than or equal to 3, right? At most, less than or 3 equal to correct. Okay, so at most means the probability of x is less than or equal to 3. So what we can do, because we have our table, we can add the probability of 1 plus the probability of 0 plus the probability of 2 plus the probability of 3 and type it into our calculator. Okay, so 0.237 plus 0.396 plus 0.264 plus 0.088. And we do get about 0.985. Now the calculator will do what's called a binomial CDF, which is a cumulative probability. However, it will only do less than or equal to probability, so you have to be very careful. It's kind of tricky. I would start with 5, my probability of success, and where I want it to be less than or equal to. Now remember, you have to label NP and X if you want to have full credit. So I just pushed second vars. Binomial CDF is directly below binomial PDF. And we just type in our values. And notice we do get something very similar, 0.984. Okay. So the probability of getting 3 or more correct. So if I want 3 or more correct, that is a greater than or equal to probability. So in this case, we would take the probability of 3 plus the probability of 4 plus the probability of 5. And we would add these together. And it is about 0.104. Now, I can use the calculator to my advantage if I didn't have a table. To find the probability that x is greater than or equal to 3, remember it will only do cumulative probability in a less than direction on the graphing calculator. So I have to think of what is the opposite of 3 or more. Well, I can do 1 minus the probability of 2 or less. Okay, and when we do so, 1 minus binomial CDF, we still have the 5. 0.25 is my probability of success. This time I want to do 2 or fewer. And if I type 1 minus and then I go down to binomial CDF in my calculator and we push enter, notice we get approximately the same answer. Okay, you are now ready to do your geometric and binomial video notes.